So in this, what
The
is the
screen is
application? You have to
such.
check from your side because other people can see the screen. Okay, so come to the introduction part. Many industries applications such as steam generators in a boiler or air cooling in a coil of air conditioner can be modeled as a two-dimensional periodic heat flow. This tutorial illustrates what it is going to explain how to set up a periodic heat transfer problem, and again it is going to explain you how to generate pre-generated mesh of a given pre-generated mesh. Now the system that is molded in a bank of tubes. So first I'll make you to understand this diagram, then I'll read the description so that you will able to understand. Now here there are series of tubes. You can see this series of tubes which having. Here we have the series of tubes we have. Here all this, you consider this all are 3D tubes. Now inside these tubes hot liquid was flowing. Hot liquid, the hot liquid which has temperature of 400 Kelvin. This temperature is at a temperature 400 Kelvin. In order to cool these pipes, the hot pipes, what we are doing is we are passing a cold water to flow on top of these pipe sections. In order to cool this pipe section, the hot pipe sections, we are making cold water to pass on the top of this pipe sections. Okay, so now what I'm going to do is, now you can first we'll understand this. The system that is modeled in a bank of tubes containing a flowing fluid at one temperature, that is immersed in a second fluid. Immersed in the sense, on cold fluid it is immersed in a second fluid in the cross flowing at a different temperature. Both fluids are water. Here they already mentioned that both fluids are water, and the flow is classified as a laminar flow. The fluid is classified as a laminar flow, and it is a steady state, which is the Reynolds number is approximately 100. Okay, the mass flow rate of the cross fluid is known, and the model is used to predict. What you are going to predict is flow and temperature fields and results for convective heat transfer. Convective heat transfer, it is not conduction, it is a convective, between from one layer to the other layer it is going to find. So first we'll read the problem again. So this is just introduction, how the diagram which is defined, description of that. Now go to the problem description. The problem considers a 2D section of a tubes bank. The semantic of a problem is shown in the figure below. The bank consists of uniform spaced tubes with a dia of 1 centimeter and which are stacked fins across the cross fluid flow. Okay, stacked fins are over here. These are the stacked fins. No, this the bottom are stacked fins we can call. So uniform space with a dia of 1 centimeter, which of stacked cross flow field. So the centers are separated by distance of 2 centimeters in x direction and 1 centimeter in the y direction. The bank, the bank has what do you say? The tube banks has a depth of 1 meter. Okay. So next, you can see this area. So this are the depth of 1 centimeter they have, and you can see it is of x centimeters along x direction, y direction. So if you cut into any section, if you cut it into any part, both are equal. So what I do, instead of taking the whole portion, I'm going to take only quarter portion of this. The dotted lines are quarter portions. Out of this whole section, if you cut it any side, both will be equal. So if you cut it in this way, any way it's fine, or if you cut it in the bottom, any way it's fine, right? So in order to solve the whole problem, only quarter or some portion we are going to solve it. Only the symmetry portion I'm going to solve it. Okay, so because of the symmetry of tube bank geometry, only one portion of domain must be modeled. The computational domain is shown in the outline in the figure. A mass flow, they have mentioned the mass flow rate of 0.05 kg per second is applied in the inlet boundary of a periodic module. The temperature of bulk temperature, this is the water temperature, cold water temperature, no, inside temperature is 400 Kelvin, and the bulk temperature of glass water, that is cold water at a temperature of 300 Kelvin. The properties of water that are used in the model are shown in the below. The properties of liquid density is this, coefficient of viscosity, thermal conductivity, and we have different cases. Okay, So using this we are going to solve. So again you will get a doubt, sir. Now here we have series of tubes, no? Then what about the other section? Only small portion we are going to draw it. Now in the settings I am mentioning that is a periodic in the sense continuous flow I am going to mention. In the settings I'll mention that as a continuous flow I'm going to mention. Okay. So now how you decide, sir? Now how you decide? Suppose you have a you think this is one section. Now here we have a tubes. Here we have continuous with equally spaced tubes you have here. Okay. Now here also there is a equal tubes which is equally spaced along x and y direction. You have equally, here we have, and inside it is filled with hot liquid. Okay. And the top of this you are passing a cold liquid, no? In order to cool that you are passing a cold liquid to cool this tubes. Why, sir? Why you are making to cool? Because we want to increase this efficiency of these tubes. What happened if it continuously hot liquid was passing in these tubes? Definitely at some point of location the tubes are going to be failures. Okay, if you keep on continuously heating these pipes, what happened? At one location it is going to break. So that's the reason, in order to increase the efficiency, what is the temperature convecting, that I want to predict it. So it is we are making cold water to pass inside. So continuously we are making water to pass. Now as I'm saying is, what I'm trying to explain you is, so this area, out of this I'm going to construct only this portion which I'm marking. No, only this portion I'm going to take it. Only this portion I'm going to take it. This area, only this area. If you cut it any side, both will be equal. So that's the reason I'm taking only this portion. Now then, sir, what about other tubes, sir? Then what could be the other tubes? What could be the other tube? So what I do is, now from this area to this area, from this area to this area, I'm going to mention this as a inlet, and this area is outlet. This is inlet and this is outlet. So then what is use of periodic? See, now here also there is inlet in the top, there is on the top also there is an inlet, and here also there is an inlet. That's the reason what we do is we'll make that as a periodic. What do you mean by periodic? Periodic in the sense continuous. So what I do is I'll mention from here to here is an inlet, and here to here is a outlet I'm going to mention. Now later what I do, so I'm going to display the whole thing. I'm going to see the results. Okay, so you can see it. I hope you understood 5 to 10% you have been understood from this diagram. So then I'll open the application, go to the workbench. So if you have workbench you can do, or you can go to the Fluent directly. You can, because I have already have a go to the Fluent. So directly you can browse the mesh file. So use 2D, going to double series. I'm going to use it thus. So from here, how you can browse that mesh file, because already I have shared you the mesh files. From there you can browse it. File, read. Read the mesh file. We have read the mesh. You can read that mesh. So where you have that mesh file. So desktop, or from the hands-on files, what I have shared you yesterday, you can just take it from there. So what you can do is you can take tube bank. You can take it as the example name is tube bank. You can consider that. So once you're done, try to take this tube bank. Okay. So here I'm going to take it this. Right, directly you can browse at the mesh file if you have mesh file. See how fine it has been generated. You can see this areas, right? So then what I'm going to do is, this is the file we have now. So then I'm going to display the other things also, but here it is showing only one now, this area. So go for results, graphics, view options. You can display all other faces. You can display this. Okay, this all are faces we have it. Okay, they have some names over there, symmetric 11 and all. Only this portion I'm going to take it here. Now what I'm going to do is, but these names have their particular ID now. For every name they have some particular ID. So go for display, you can see their names. Okay, all no, you can undo this symmetry 11. So which is a symmetry 11, the top portion is a symmetry 11 and symmetry 13. Okay, sir, why you are why I'm making you to understand, because using this names itself, I'm going to give the neighborhood selections. Now symmetry 18, they are already given the symmetry 18 as a neighborhood selection. Symmetry 24, okay, this all which is marking with yellow color, this, and wall 12. So wall 12 is your outlet, and wall 21, this is wall 21 is your heating object. Wall 3 is also your heating object. Okay, wall 3 and 21, and wall 9 is your inlet. And wall 9 is your inlet, wall 12 is your outlet. Then the interior mesh, this is the interior mesh. Now remember, this wall 9 is your inlet, wall 12 is your outlet. So then what is the ID for that? First you see the ID for that. Whenever you click on this boundary conditions, no, so you see wall 12 is ID is 12. This is very important. Wall ID is very important. Wall 9 ID is 9. Okay, sometimes it is going to be changed, this ID. How this ID will be created? System automatically generate this ID based upon your name selections. It will generate here. Okay, wall 24, no, we have this ID. Now go to the general. The first thing is, now view the lens are in terms of, I'm going to use scale option. So view lens are in terms of meters. Okay, so how you want to scale it? I want to, because this lens are in terms of meters. Now I want to view this lens are how, what is there? It is are all are in terms of centimeters. You can see the units are in terms of centimeters. Then now I can convert into centimeters. Okay, just try to scale it. We have been scaled it, right? We have been scaling that object. Now once we done it this, then what you're going to show? So I'm going to use, so then we done, no, just you can examine the whole mesh and all. So once we done, so then how the our intention is to create a periodic zones. So that is our target now. So calculate a solution using pressure based PCD Transient and coupled solver, plot temperature profile and specified ISO surface, and also create a periodic zones. Why, sir? What is the reason of periodic zones? Because you see guys, no, whenever I'm creating this graphics, no, because everywhere you have inlet, then how you are going to assign? See, now whenever you take this whole object, now here is the inlet and here is also an inlet. Okay, this is inlet and this is also inlet. So in order to define that way, because everywhere we cannot give inlet, right? So what we do is we'll create a periodic zones. Okay, the system will know, using this ID I'm going to create a periodic zones. Sir, how do I create a periodic zone? Just click out on this command prompt, just give enter, just click it here, enter. So how you want to create a periodic zones? Okay, so mesh mesh modify 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 zones make periodic, make mesh slash modify zones make periodic. All right, I'm going to create that. Sir, why, sir? Again I'm saying why we are creating periodic zones, because we have different inlets, we have series of tubes. So in order to make continuous, we are creating this periodic zones. The same similar component we have in the next example, or next or before example we have that. Even there is already they have converted as a periodic, but here they have not converted as a periodic. You see, So whenever you go to the models, no, you cannot see that periodic. Here you cannot see the periodic. So once you create a periodic, it is going to create here. So that I'll show you here. So remember this wall 9 and wall 2 are your periodic zones. Okay. So mesh modify zones. Please make a note of this. Mesh modify zones make periodic. Just give enter. So periodic zones, how many? What is a periodic zone? Periodic zone is this is inlet your 9 is your periodic zone. I'm going to give 9 as a periodic zone. What is mean by shadow region? Shadow region is opposite to that, right? This is our outlet. So that what is the ID for that? That is ID is 12. Okay. So it is a rotational periodic. No, it is not a rotational. It is a translational periodic. It is a rotational. It is not rotational. It is translating. Water has been translating. No, it is not a rotational periodic. I'll be giving no. Okay. So you want to create a periodic zones now? Yes, I want to create right now. Yes. So use auto detect vector. Yes, I want to detect automatically. Yes. So zone 12, no, zones 12 deleted periodic zones. Sir, can you show me that periodic zones? Again, go for general display. Now you can see periodic 9 was created over there. So I'll undo this all. You can only display this thing. Now you see, just try to fit to the screen. You see, this is your periodic zones and this is your shadow region. This is your outlet. So we are going to apply over here the mass flow rate. We are going to apply this 9. We are going to apply the mass flow rate. Okay. So just try to display it again. So once we done it, then try to close it. Now again come to the general. So it is a pressure based, absolute, steady, and it is a planar component, right? So once we define this, and the next case is we are calculating the temperature. We are calculating the we are calculating the temperature. So that's the reason what I do is go for you can also check the checks, report the quality, everything is fine. Go to the model. So temperature is important, right? I'm enabling this energy equation. Yes. Then what could be the next step? Okay. So what could be the next step? I'm going to, it is a laminar flow. I'm not going to display that. It is a laminar flow. Okay. I'm not going to disturb this. So let it be this material. So what it was saying, they specifically mentioned that is a water. Here, they already mentioned that is a water. Both fluids are water, no? Both fluid, the mass flow rate, they have mentioned both fluids are second fluid, all are water, both water, water, they have, both fluids are water. You can see both fluids are water. Okay. So this is the description they have given. So fluid, but here I have only air, no? Go for create or edit. So change, someone asked, I think Anuraga, someone asked, sir, I am not able to create a carbon dioxide. So what you do is put it this metal type to fluid, put it to fluid or put it to solid, then you can find the carbon dioxide fluid database. So you'll have carbon dioxide, it will be there. Okay. Now I required fluid, right? Put it fluid. So you can go with fluid database. I'm going to create water liquid and copy that. Okay. So what parameters they have given for water liquid, just go for create or edit. Density is 998, 0.82 kg per meter cube. So that I'm going to use it 998, and the specific heat is 4182, and thermal conductivity is 0.6. Both are similar. Like viscosity is 0.00. Yes, both are same. The same similar cases they have given. Okay, no worries. So once we done it, just close it. This metal was go for cell zone conditions in the fluid, edit it, and change type to water liquid. Okay. So you can save it this, or you can file, you can save solution data. You can go with here. If you want to save, you can save it here. Okay. So then you can go with the boundary conditions. So in the boundary conditions, I'm going to define this as mass flow rate. They have given here, for periodic 9, they have given the mass flow rate. So how much they have given the mass flow rate? So they have given here the completion domain is flow domain is the mass flow rate is 0.0 kg per second. They have given this. So that I'm going to give the mass flow rate. Okay. So yeah. So go for periodic 9. Go with here periodic conditions. So in that you can specify the mass flow rate, that is of 0.05 kg per second, that I am given. I'm going to define this. The bulk temperature 300. Yes, that have been given. Now, but what about this? These are the hot tubes, right? These are the hot tubes that I'm going to define it. So wall 12, wall 21 and wall 3 are your hot liquids. So go with wall 12, edit it. This is, you can rename it, wall, you can rename it wall bottom. You can just go with here, right? Wall bottom. What is the temperature over there? Uh, thermal temperature, you can put it here, which is having 400 Kelvin. Okay, so I'm going to use it that. And wall 3, wall top, you can mention this thermal temperature, you can put it to 400 Kelvin over there. Both I have given this, wall top and bottom, right? So once we have given this, so go to the dynamic mesh is already be done. Find mesh reference values, I'm not going to do. You want to cross check, you can cross check it that whatever the inputs we gave, everything we can see here. So go to the solution methods. I'm using here coupled base solver. Sir, what is meaning of this coupled base solver? Coupled base solver, or we are going to solve pressure based problem, right? I'm going to use coupled solver. Oh yes, every time it is going to happen like this. Automatically it has been closed. So what I do is, might not be there in this error because we are using 16 version. Sometimes it is getting crashed automatically. So what I do is, again I have to instead of this, I'll go with workbench directly. Both are same. So here you can take it. This would be better. So you can mention this as periodic flow. Periodic flow. Anyway is fine, no? Anyway is fine. If you have gem mesh file directly, you can take it. I'm going to import the mesh file. So go with the double precision. I'm going to use it that. Again, we have to do from the beginning. Okay. So this I'm going to meters, centimeters. Check, report the quality, display, planar. So you can just give enter. Mesh, you can go with here mesh slash modify zones, make periodic, you can give it here. Mesh dot modify zones, make periodic. Mesh modify zones make periodic. So which is your periodic zone? 9 is my periodic zone. Shadow region is 12, and it is not a rotational periodic, right? No. So you want to create right now? Yes, I want to create right now. So auto detect, yes, I'm going to use it. Right? So it has been created. So go to the models. Energy is important. It is a laminar flow. In the description it is mentioned. So materials, create or edit. So in the Fluent database, water liquid, I'm going to take it that. Okay. So go for cell zone conditions, go with edit, put it to water liquid. Okay. So this we have given. Now in the boundary condition already we go for periodic conditions 0.05, right? The mass flow rate is how much it was? 0.05 we have given. 0.05 is the mass flow rate. I'm going to use it. And this wall 12, edit it. This we can go with here. Okay. So thermal temperature, that is of 400 Kelvin. Edit, and you can go with the top. Okay, so you can go with here, right? Both, and I think both top temperature 400 we can be with this, right? This up to here we did in the last session, so you can save it this for future reference. So go for reference values. I'm not going to use solution methods, so I will use coupled solver because it is a pressure based problem. So I'm using coupled solver. Okay, so pressure, movement, and second order, yes, let it be using PCD transient. So once we done it this, so what is mean by PCD transient? What do you meaning of this PCD transient? You'll be getting it out. So whenever you are solving a what do you say, pressure based including the temperature, we have to enable this PCD transient. Okay, so that I'm going to use it. So go for solution controls. I'm not going to disturb the solution controls. I'm not going to disturb the solution controls. And monitors, and someone was asking about this, what do you meaning of this residual monitor? What do you meaning of this residual monitor? When you go with edit, so in the residual monitors, see, the maximum iteration it can be go up to 1000 iterations. Whenever you're plotting x velocity, y velocity, energy equations, it can be go up to 1000 iterations. So you want to increase, you can increase this. This is the maximum limit. Now sir, I want to go for 5000 iterations. Sometimes you have huge problem to solve the fluids, then we'll go with maximum. But as per the default cases, it will have 1000 iterations. Okay. So next case is, what is meaning of this equation, sir? Whatever you calculate, whatever you thought it will calculate, it will calculate x velocity, y velocity, and energy equations. These are the default cases with precision of 0.001 with minute precision. No sir, I don't want to have velocity because velocity doesn't consider. Then you can undo this velocity, you can undo this in parameters which is not required. Okay, so if you want, you can enable this. So one is monitor check and convergence, you can check it this. Okay, so this way we can use it. So once we done, or you can put it to none also, it will be none, you can do it, or you can go with absolute, so we can do it. Okay, right? Now which region you want to plot the graph? So I go for here. First I'll initialize whatever inputs you are given, no input velocity and all, just go with hybrid initialized. So go with run the calculations, or we have given the bulk temperature, right? Sir, what about this cold temperature? See, we have to define this cold temperature, right? What about this cold temperature? That is called patch. So go for solution controls. Here we can have patch. Solution methods, we can go with patch option. Initialized, yes, here we can know calculation. So here we have patch, that we can go for temperature. How much it was having? 300 Kelvin. That I'm going to give it here. That to fluid 16. So you can patch it that. Right? just go with patch. So try to close it here. So once we done it, run the calculations. So you can go with here some 500 or 600 iterations, you can go with that. So probably I'll go with here 350 iterations. I'll go with probably up to 350 iterations and try to calculate. You see x velocity, y velocity and energy are default you have. So you want to give another parameters, you can also define that. Yes, now it has been converged at 311, but we gave up to 350, right? So solution has been converged over here. That means up to next stage, then it will be constant. So try to give okay. So go for graphics, counters, setup. What no? I want to see the type of pressure. You can see for pressure. Okay. So you can pressure which region you want to see. So let it be pressure. Try to display it. Just again. Now here there is a small thing. Just go with the display that will have this pressure. Okay. So there is more pressure over this region. And sir, can you display the other walls also? Go with what do you say? Graphics view. You can display all other symmetry walls also. You can display that. Okay. So this we have it here. Okay. So this way we have the pressure graph we have. Then how could be the temperature, sir? What could be the temperature? Then you can go with here temperature. So counters, setup, want to display the temperature, then you can put it here. See, this is your cold water. How the temperature exchange was happening here, you can see this area. See, this is the cold water which is passing, and now we are reducing the heat over this area. See, you see how the heat is getting exchanged or heat has been getting transferred. You can see that how it is getting convection. Okay, so this way we have you can just plot it, whatever result you want, you can plot it there. Okay, so this is one thing. Sir, can I plot the temperature, sir? Can I plot the graph for that? Yes. Now for temperature I want to plot the graph. Sir, how do I create, sir? So you can just go with create a thing. So first, either here in the Fluent also we can plot the graph, or you can go with the post process of Fluent, you can also plot there. First, sir, how do I plot? Go for surface. We can go with here, which region I'll go for surface. Here I can go with iso surface. Over here now we know the total distance how much we have. So you can know, we know the total distance, right? 4 centimeters, and this could be 1 centimeter, and with this area we are having that. So using this I'm going to use it. So mesh, using mesh, because we have mesh now, along in the which direction x coordinate, we can give it here. Okay, so new surface. So this is the first coordinate I'm going to create. So you can just rename it 0 point location. You can give 0.01 location. The value you can give it 0.01, and new surface name you can go with the x equal to 0.01. You can give it at 0.01 meters location. You can give it here. You can create it. Okay. So new surface again, like similarly you can create like 0.1 here, it will create 0.2, like similarly you can go with this. So 0.1, 0.02 you can give it. So this is also new surface x equal to 0.02. Okay, em you can give. So try to create. This is one thing, and again 0.03, and this is like x equal to any name you can give it, but this value should be must. Okay, x equal to 0.03, and you can create it. So all this it will be created here. You can see 1 2 3, it is going to be created that. So now how to plot, sir, that thing? So go for here plot options. So here you can find it plots, right? So go with plot, xy plot, create setup. So which region? So you can go with what you want to plot. I want to plot temperature. Okay, So what variable you want to go? Static temperature. So this is direction vector. Which region? These three regions I want to plot. 1, 2, 3. So these three regions I want to plot it. So first I will plot it one, then I'll go. Yes, it is your wish. So this along y direction, the temperature should be in the y direction. So belong x direction, try to plot it that. You have this. Okay. So how it is getting plotted, you can observe that. Along the x distance, y distance, you can have. Sir, can I change this type? No, everything, no, you can see here. White color indicates 0.1 location and red indicates 0.2 location. X is equal to 0. That is, sir, can I change this style? Yes, you can change that. Go with cows. Okay. The first one is which pattern you want to give. So first you select any one of them. So you can just select one, just go with cows. What representation you want to give? I will give this. You can go with any line. What color you want to? I'll go with the blue color. Just apply this. Okay. So then you can go with your cows. Okay, there's any color you can go, and you can go with here some light blue. Already we gave, no? Dark blue or dark green you can give. Try to apply. So these are the default settings you can go with. Cows style, how you want to give, no? You can give the style. Okay, so once you select three of them and try to plot it again. You see the color how it is representing. You can plot it that. Okay, sir, how could be the temperature or this you can save it, no? Sir, how do I save, sir? So you can write to the file, you can write it where the which location you want to save, you can save that. So for example, I want to save in the desktop Fluent. You can create a folder, you can save it that. What temperature? You can save that as a temperature. Okay, just put it save, it will going to write that. Now sir, then how to import that file again? So you can have file, right? Setup. So you can add the file. So go with the desktop where you've been saved. So go to the Fluent location. Fluent. So in that we have temperature, right? Just now we did it. So you can just go with it. Then you can add it. Sir, why it is showing add again? Because you want to compare both the results. See, now this is the temperature for 0.05 mass kg per second. It is. I'll go with 1 kg per 1 kg per second. You want to go with it. So both you can compare it. How changes have been happen. You can compare that. Okay. So this is add. Then you can go with plot. So both will be plotted. What changes have been happen. You can plot it that. Okay. So first thing is what you learned in this exercises. Here you learned how to create a periodic zones, and the next one is how to define the mass flow rate. You have second thing you have learned, and third thing is modeling the periodic heat transfer with specified temperature boundary conditions that we studied, and using pressure based, how to solve the pressure based problems that we solved. Next, how to plot the graph and how to plot the isosurface, how to create isosurface. Isosurface in the sense the new surface or the new points, how to create, that we studied here. The 4 to 5 concept you studied today. Okay, so this all concept you have to explain to your students. That is very important. Sir, when I can tell all this stuff, once you get good practice on the software, then you can explain fine. So that's the reason I'm saying you have to practice 1 or 2 times. You have to practice because you are the trainers. I know how the people of trainers will be there. If you practice 1 or 2 times, then it will be feeded. Okay, any doubt? Gokul, Santosh, Ranjit. Santosh, have you received that hands-on files?